Whoa, new video evidence that will blow your mind. The video that I'm about to show you is one of the very few, I would say 3 videos that I have that really show the power and the movement of the ground of these big earthquakes. And this video is controversial right now because people think the ground is moving in a very strange way. So it looks like it is swirling like a kitchen swirl. But before I show you the video, I want to show you the other 2 that will blow your mind. So the first one, because that is helping you to understand how these fault lines work. And the first 2 that I'm about to show you are only one earthquake in that magnitude. But the one in Venezuela, the 2 in Venezuela are 2. That's why the movement is even weirder there. So the first one is the Myanmar earthquake, magnitude 7.7. And this is one that you have to stop and replay multiple times to understand how much is going on. Because if you see it the first time, you're like, okay, I see this, the pavement cracking. I see the electric gate shaking. Maybe you already see that there's something falling over, a tower, a tree. But many people overlook the first few times, and I was one of them, what the ground is doing. So look at the right corner of the gate and behind the gate, what the ground is doing. This is strike slip. This is also what the San Andreas fault can do. If you stand here, your friend stands here, it displaces you. So now that you see it in slow motion, do you see it? Do you see it? It's amazing. So stop it, replay it a few times. Look at how the ground moves and how a crack opens there. But then look at what just happened. Mindanao, where people said, wow, the ground felt like it's waves. And then look at this, what is happening with the ground? The crack is opening and it is indeed shaking like waves. And once you've seen that, you're prepared for the newest surveillance video that has been made. And you have to look at a few things. I'll play it once and then I'll ask you, did you see this and this and that? And we play it again. So here we go. Watch what is happening with the people running out of the buildings, but look at the ground. Look at the ground. People can't even stand. They're falling over. But I have to play the video again. Did you see in just a few seconds the whole tower building that is collapsing in the background? There's so much going on. So I'll play it again. Look at the people, look at the swirl, and look at the building that is collapsing. And within 39 seconds, we did have 2 strong earthquakes. And now it's circulating all over the internet right now that people are saying, okay, yeah, because this movement is because that earthquake was basically 2 earthquakes were moving the ground in zigzag, because one earthquake was making the ground shake and move in this direction and the other one in that direction. But I can show you the beach balls that have been released, the moment tensors of the USGS, and that tells a different story. It's very interesting. And here in this video, you see how the fault broke, how it ruptured, widely opened. Looks quite scary. Listen to this, the following. I have asked the question, and you have asked the question multiple times, and I have made 2 videos about this. Why did so many buildings fall, collapse in the same matter, fall over? Was this just building materials, or was it also the ground movement? If you're interested in what they found, the building materials they found in the rubble, check the video in the end screen that I'll later put there. But this earthquake, since it happened, rising toll of people lost, estimates are 69 to 70,000 people missing, and the time frame, the 72-hour window where it's most likely to really still find people alive, has ended. So you can do the math. So what we can do now and have to do now, since we're getting the first detailed moment tensors and fault models published, we have to look at what did rupture, which fault line, the whole fault line, parts of the fault line, or was each quake a different fault line? So what actually did break beneath northern Venezuela and how? That is also important. So we have to say, it starts slowly. Underneath the northern edge of Venezuela, we have the Caribbean plate, and that is grinding eastwards. It's moving, it's pushing eastwards past the South American plate with a speed of roughly 20 millimeters a year. That's 2 centimeters. That's an inch and a half, something like this. And this is a transform boundary, like the same kind of boundary like the San Andreas Fault in California. I think everyone knows what that is. Two plates are sliding horizontally past each other, and rather than diving beneath each other in a subduction zone that we usually have along the Pacific Ring of Fire. Even the rates at which they move per year are almost the same. The San Andreas Fault moves a little faster, around 30 millimeters a year. That's 3 centimeters, 2 inches, something like this. And the motion, it's not like gliding smoothly. Rocks along the fault, they lock into each other and they block it, and then they're locked and loaded while the fault is moving in other places. And that builds up pressure, of course. Strain accumulates for decades, even centuries, like Cascadia subduction zone, right? 500 years, something like this, until it overcomes that blockage, the strength of the rock that holds that blockage, and then the fault breaks. And that is what we've seen on camera in these 3 videos, although it looks so much different. Myanmar, we see the straight strike slip. Then we have the Mindanao, which looks like waves. And then we have the kitchen swirl here in Venezuela. So why does this look so different? June 24th, 2026, it broke in a sequence that seismologists to this day are still trying to fully understand, untangling the web of information that they have. At 22:04 UTC time, magnitude 7.2 was the first one that ruptured near Yumare in the Yaracuy state. 39 seconds later, before the first rupture had even fully settled, was still shaking from the first one, a magnitude 7.5 broke along the same fault. It's the San Sebastián fault system. And there is speculation that it was not 2, but 1 earthquake, because it was traveling, the fault was rupturing. For now, let's treat them as 2 separate events, 2 big jolts. USGS is calling both earthquakes a doublet. This is what it's called. 2 earthquakes of similar size striking in close succession on adjacent fault segments. You see the maps of the faults behind me. But again, some seismologists, including teams in Italy and China, they were the first ones that came up with this. They're analyzing the ground deformation from the Sentinel-1 radar satellites, and they say, or they found that these 2 events are so closely overlapping that their models treat them as one single combined rupture with 2 pulses of energy release. We have a geophysicist, Sylvain Barbot, put this ambiguity plainly. The 2 pulses came so few seconds apart that whether this was 2 earthquakes or 1 earthquake breaking in 2 stages is still an open question, and this question will only be answered by the data that they need to analyze and collect. So the fault models they definitely agree on the scale, and it's considerable. While I'm explaining this, you see the damages in the latest images behind me. And then we're coming to the beach balls, the moment tensor, that will explain the swirling and the mystery of this. The scale is considerably. The INGV in Italy, we normally hear about the INGV, about the supervolcano in Campi Flegrei that is escalating there right now. Have a Campi Flegrei playlist, by the way, on my channel if you're interested in that, and you should. More than 6 million people living on a supervolcano. But INGV is looking into this earthquake as well. They're working from the satellite data. They modeled a rupture that is running 210 kilometers by 30 kilometers along the fault. That's roughly 170 miles by like 22 miles. Basically from near Moron in the west to northeast of Caracas. So the rupture began near Moron and tore eastwards towards the capital, Caracas of Venezuela, at around a speed of 3 to 3.5 kilometers per second, like roughly 2.5, 2.7 miles per second. And it has produced up to 2.5 meters of slip at depth, almost 10 feet in the first pulse. But then came the second. The second one was more energetic. 39 seconds later, has reached a maximum slip of 3.6 meters. So that's almost 12 to 13 feet offshore, north of Catia La Mar. So this is what the Italians are saying. USGS has modeled a slightly larger combined rupture of around 230 kilometers long, 170 to 180 miles long by 40 kilometers, 27 to 30 miles. And a team at the Beijing University put the peak slip even higher at nearly 4.5 meters, like 15 to 17 feet, concentrated roughly 70 kilometers, 57 miles east of where the rupture began. And this is important, guys. The shallowness mattered as much as the size of the earthquake. The main shock broke at a depth of only 7 kilometers, 7 miles deep, which delivered the energy to the surface in a brutal way. Very, very efficient. And the direction that the rupture actually traveled, here it comes. This is what turned this from a disaster into a catastrophe for the capital, for Caracas. The break initiated about 170 to 200 kilometers west of Caracas, 150 miles to 250 miles west of Caracas, and then it propagated towards the city. So when a fault breaks in the direction of a population center, densely populated area, it's coming towards it. The seismic energy piles up ahead of the advancing rupture. It's breaking, but the waves are ahead. That has a focusing effect that intensifies the shaking in the direction that the rupture is traveling. And Caracas, the capital, right in the path of that focusing, right there. So this explains how a city nearly 300 kilometers, 220 miles from the epicenter suffered the collapses that we have seen. In the Altamira area, Los Palos Grandes, and why the worst destruction even reached the coast, La Guaira, which is the worst, where we see all these towers that have collapsed. And then out towards where the second larger pulse released its energy offshore. So the fault that did this has been on the maps for several years. And we get to why it looks so swirling in the video in a second. the San Sebastián system, part of the broader Boconó San Sebastián El Pilar boundary fault system that runs more than 1,000 miles, 1,300 kilometers across northern Venezuela. It's a big, big system. It has long been identified as being capable of a magnitude 7 or even larger earthquake, which it has done with the 7.5. The neighboring Boconó Fault last ruptured in the catastrophic Caracas earthquake in 1812. This was the largest earthquake that did strike Venezuela since 1900. And the knowledge that they did have that this could happen again, it was, well, was it widely known, or was it sitting, I would say, it was at least sitting in the scientific literature for decades. So that earthquake that happened on June 21st had turned that long-standing forecast and warning into a measured, dated, and fully recorded event. I mean, in the 60s, they had the big earthquake where the towers collapsed in a similar way. They wanted to change the codes. Did they? Obviously not. The real version of what models had only been able to anticipate materialized on June 24th, and not once, twice. The hazard is not finished. The USGS estimates a near certainty of a further magnitude 5 aftershocks and a significant chance of a magnitude 6 in the weeks ahead. And look at the buildings that are still standing. They look like hollowed out. Bombs thrown at them. They will collapse. We will see many, many more buildings collapse. That is my estimate. So even up to magnitude 6 in the weeks ahead, they just had a magnitude 4.8 and a magnitude 4.7 aftershocks, and people ran out of their homes, and they said it was shaking intensely. Only a 4.8. So that shaking, the big ones, has loosened slopes across the affected region. We are expecting heavy, heavy rains. They're already dealing with flooding in Venezuela that will bring down landslides onto the ground that is already broken. We can say that what happened on June 24th was the violent beginning of, unfortunately, a hazardous season that will run for months. We have international aid teams there. You see videos of the German teams, the US is there. But you know, if you look at the video of the massive crack that has opened, amazing, amazing and scary. And now let's talk about the swirling. So the Myanmar 7.7 earthquake video shows something very specific. The ground is cracking open. One side of the surface shifts sideways against the other. This is a surface rupture. That means the fault break has reached the ground. You are not seeing just the shaking. You are seeing the actual fault movement through the surface. Now, in the Mindanao wave video where the ground is doing this, it almost looks like water. That kind of motion can happen when earthquake waves travel through soft, loose, saturated, or weak ground, so the surface can roll, it can bend, it can move like a wave passing under your feet. And now look at the Venezuela video again and at the crack that is also opening. They look different. People are falling over. The ground does not seem to move in one clear direction. It looks like it's pushing, it's rolling, and it's twisting at the same time, almost like a circular movement. But that does not mean that the fault moved in a circle, and that does not mean that the earth underneath was spinning. What it likely means is this: the people were feeling several earthquake wave motions overlapping at once. An earthquake does not send out only one kind of wave. First come the P waves, then the stronger S waves, then the surface waves, and then the love waves. Love waves move the ground side to side. And then the Rayleigh waves can create a rolling motion, almost like an ocean swell moving through the ground. We were dealing with love and Rayleigh waves in the Mindanao earthquake. I have explained it in that Mindanao video. And usually all those waves arrive in a sequence. They stand up in line. But in Venezuela, the situation was way more extreme. 39 seconds between two major quakes. So the first earthquake hit, then only 39 seconds later, the second and even stronger quake hit. So the ground was not being shaken by one clean earthquake pulse. It was basically hit by overlapping waves from a double earthquake. And that's why the motion can look round. One wave pushes one way, another wave arrives from a little bit of a different angle, surface waves begin rolling through the ground, and then a building, a person, or a camera does not feel those waves separately. It feels the combined motion, forward and back, side to side, rolling and twisting. That can look like a circular or zigzag motion, even if the fault itself moved mostly sideways. So that brings us to the moment tensor. These beach ball diagrams that the USGS shows us, they show how the fault was moving underground, what you couldn't see. Both beach balls from both earthquakes point mostly strike-slip movement, San Andreas fault style movement. Strike-slip means sideways tearing. The ground blocks slide past each other horizontally. So this was not one plate diving underneath another. But also the beach balls can be confusing. Each beach ball shows two possible fault planes. One is the real fault that slipped, and the other one is called the auxiliary plane. That does not mean two faults broke. We have to really make that clear. That also does not mean the ground moved in both directions. It means the math gives two possible planes that could explain the same seismic waves. So to know which one was the real rupture plane, scientists need more data, aftershocks, satellite deformation, GPS movement, mapped faults, and detailed rupture models. So when people say the first quake moved one way and then the second moved perfectly perpendicular, that is not proven by the beach balls here that we see. The moment tensors do not prove a perfect X pattern. They do not prove a confirmed circular rupture. What they do show is already enough. Both quakes were shallow. Both were mostly strike-slip. Both happened in the same broad transverse fault system. And the second major hit before the first shaking had fully died away. That's the key difference. Myanmar showed clear surface rupture. The fault itself visibly cut and displaced the ground. Mindanao showed wave-like ground motion, surface behaving like a flexible layer while the seismic waves were passing through. Venezuela may have shown overlapping wave motion from a doublet. Two large earthquakes sending waves to the same region almost at the same time. And this is why people could fall over. This is why the shaking looked so chaotic. And this is why it seemed round, not because it was actually moving in a circle. So I hope this explains the mystery a little bit. If you want to know more about the building materials that they found in the rubble and some really interesting images, and did they do some mistakes in construction? It is still not clear. Some say, well, you know, what we see on camera is not load-bearing columns because we should see the steel rebar in the concrete, but others say this was faulty, this was concrete mixed with this soft, faulty material. I have analyzed this in the video here in the end screen. I hope to see you in a second, guys. Stay safe. Be prepared. Bye-bye.